Alright, welcome guys to day 3 of Matplotlib. So we're going to be talking about common plot types such as line plot, scatter plot, bar chart, and histogram. So we can start by importing our library. Import matplotlib.pyplot as PLT. Alright, so let's get straight to the demo. So we are going to be tackling the line plot and scatter plot for demo 1. All right, so we have our data here. So for the line plot, we want to check your battery level over the hours. All right, so the first thing that we need to do right now is to create the figure, then the axis. All right, plt.subplots 1x2 shape. All right, and this time around we're going to do something different. But first of all, let's run the cell so you get to see something, so you can have a look at the size of the figure. All right, so let's try something new. We can come over here and pass in a keyword called fixed size, which will help you change the size of the figure. All right, so once we run this, you will now see that our size has been able to change. So this is a 12 by 3 inches. All right, so you can play around with this and add different sizes. Since we've been able to get our figure and axis, all right, let's try to now make a line plot. All right, the idea right now is that we are creating a 1x2 grid, all right, which is the first axis and the second axis. So we're going to create the line plots here and the scatter plot here. All right, so we can create a simple line plot just like we've been doing. All right, we access it with the index of 0, and then we try to plot the hours versus the battery. So once we run this, we will now see that your battery continues to drop the more time that we have. So the more the time, the more the power drainage. So you can see this is a downtrend. So the line plot helps us to identify trends. So a scatter plot helps to show relationships. So you can see we're trying to check the relationship between study hours and test score. So we can start by assessing the second axis. But this time around, we're going to use the scatter function to be able to get our plot, and then pass in the study hours as the x-axis and the test score as the y-axis. Once we run this, you'll now see that it feels like there's a cloud of points moving in this upward direction. So you can see that there's a positive correlation between study hours and test score. It could literally mean that the more study hours you get, the more likely you're going to have a higher test score. But there's something different here. Someone spent 5 hours and still got a very low test score. So let's say sometimes the quantity of time might not really depend. So rather, it could depend on the quality of material that the student is using. So this is how we get to do a simple scatter plot. All right, let's try to do something like showing the image. All right, so once we're able to show the image, see we have something clean. All right, let's see if we can make it more clean. So you can just come over here and do something like a tight layout, which helps you to be able to clean the layout. All right, so we'll run this and you can look closely and see how clean it looks, as if the figures and the labels and the axes have been cleaned or polished, so that we have something as nice and beautiful as this for a very good or beautiful visual representation. Now we go to our next demo, where we're going to be talking about the bar chart and the histogram. Alright, so we will create a 1x2 grid using the PLT, the subplots, and then We pass in a fixed size of 12 by 3 inches. The next thing we now need to do is to access the first axis with an index of 0. And then for us to be able to get to a bar chart, we use the function bar. Now we're passing categories as the x-axis and spending as the y-axis. Run the cell, and then you can visualize your data. You can see that you spent more on food compared to transport and others. So this could help you adjust or manage or modify your monthly spending. Then we can now go to the histogram. We try to access the axis with an index of 1, and then we use the function hist for our histogram, and we'll pass in the commute time as the data. Then you can now observe that this could be difficult to read, so we try to pass in bins. This is a keyword which helps us to be able to split our data into groups. So it allows you to be able to know the amount of buckets or bars that you want to split your data into. So these are the bars. So you need to know the amount you need to split it into. So once I run the cell, you'll now see that we have 5 bars. So we come over here to try to make it easy for us to be able to count the number of bars that we have by passing in the keyword called edge color. Then white, W for white. So you can easily count your bars right now. 1, 2, 3, 4, 5. All right. So let's see how we can read the visualization. So you can observe that we're using the data commute time. So this could be the amount of time that you get to spend traveling from work to home, vice versa. So you can look over here and see that you have less commute times. That is less traveling times from work to home as the longest bar. Therefore, you can see that this is the x-axis and this is the y-axis. And the y-axis is our frequency and this is our data. So since you have less commute times here, which is falling under the tallest bar with the highest frequency, meaning that you could literally have frequent good traffic days. So you can see that that's not the only story, because if you now look over here, you see that this is way shorter than this. So you could literally have an average traffic day over here, and then all of a sudden there's now a cluster of bad traffic days, spending like 35 to 40 minutes traveling from work to home. We could try to do something else, like drawing a vertical line, and then I'll let you know what this does. So let's say we try to come over here and pick the middle, which is 25. And then once we run this, you can observe. So you can see that there's a line, which helps for a separation. It can help you to be able to see how you can read the data on the left and on the right. So it can help you to compare. So let's see how we can change the color and the style. Change the color of the line. You can just pass something like this. Let's say red. You can see that this is our line. If you feel like it is too thick for you, you can still come over here and change the line style. Let's say dashed. And once you run this, you can see your line is dashed. You could play around with this. You can still have the same thing. You have something like this. So you could come over here and play around with this. So let's leave it dashed. So once we're done, we can now try to show our image to keep it clean. We can make it more clean by using the function plt.tight layout. And there's something else you can also do when it comes to the bins. Sometimes you need to be able to try to modify your bin to be able to get something that you can easily read for your histogram. You shouldn't always try to stick to the default settings. So I was able to figure out how they got a bins of 5 over here with a little bit of math in the background and a code. I can come over here and paste it. Then you can now see that this is the math I was able to do, and this is the code for it. So the idea is that we have a range from 10 to 40. So we need to figure out the count. How many times did it take you to count from 10 up onto 40? Which is 40 minus 10 equals to 30. And then we now get the step. So the step is now equals to the count, which is 30, divided by the number of bars that you want to split your data into. Let's say you want to split your data into 5 bars. And then you can now see that it will give you 6. And then you now come to the bins. You try to get the list of the data by using the step. So let's say we're trying to count from 10 to 40 with a step of 6. And then you can now see that 10 plus 6 is 16, plus 6 is 22, plus 6 is 28, plus 6 that's 4, plus 6 40. And this is the code for it. So let's try to remove the comment, then you observe closely and see that the count is equals to 40 minus 10. The step is now equals to the count divided by 5. We put it in an integer because there's a likely possibility that the division will return a float, but we'll need it to return an integer to avoid an error. So we'll now get the bins by putting a range of 10 to 41, whereby 41 is excluded. So it's like 10 to 40. And the step will give us 5 over here. Sorry, and the step will give us 6 over here. And then you can now see we try to put it in a list. So if I should run this particular cell again, you can now see that we have 10, 16, 22, 28, 34, 40, which is the same as this over here. All right, let's say we try to get this entire line of code. And then we come over here, then we paste it. Let's say we remove this. Then you can now observe that what I now need to do is that since I've been able to get my bins, I can now pass it to the bins by changing this 5 to bins. So therefore, we expect it to return the same thing. So you can see we have 1, 2, 3, 4, 5. Let's say we want to split our data into 6 places. We can just come over here and change it to 6. Run the cell, you can now observe 1, 2, 3, 4, 5, 6. So you can keep on modifying the bins to be able to get something you can easily read. So you can come over here and see that that was how I was able to get the math and code for us to be able to pass in our bins. Let's try something different. So let's say we try to comment here. And then we can now change this into a list of our own manually inputted data. Let's say we have something like 10, 20, 25, 30, 35, 40. Right, let's try to put 15 here. 10, 15, 20, 25, 30, 35, 40. Alright, so you can come over here and observe. Let's say we do not want to observe this particular combo time over here. Let's say from like 10 to like up onto this range. let's say we just want to see only from 20 to 40. You can still come over here. What we just need to do is come here and adjust the list and remove 10 or 15. Then we run the cell. Then you can now see that it starts from 20. That means you have a cluster of bad traffic days compared to a 20 minutes to 25 minutes, time interval. So you can see that you can easily adjust your bins and do so many other things with your data. All these that I did just to let you know that sometimes you can try to play along with your code, not just sticking to the default. So you can play around with everything I've been able to give you here. You can still go back to the video where I was able to talk about the math and code. If you do not really understand it, you can calm down, take a look at it, and try to even see if you can form something out of it. That will be good to be able to help you retain more of everything I've been able to discuss about the bar chart and the histogram. Before we go over to the solo challenge, let's try to revert this to something that we can easily read. So I can just comment this and just leave this as 5. I can just like try to this is like this. So this is something that we can easily read, and then we can now go to the solo challenge. So this is for you. So this is the formula for you to be able to get the arrow so that you can plot your histogram. So you try to make a 1x2 grid and plot this on the left and plot this on the right. So this is your data. So you could try to understand that this is what you get to estimate before you get to spend for a particular day, and this is what you actually now spend. So just try this. So you could pause the video. All right, so the first thing we now need to do is to create our figure and axis. We use the function plt.subplots. The fixed size of 12 by 3 inches. Let's run this. All right, that's progress. Then we come over here. Then we try to plot our scatter with a function scatter and passing our data. So estimated as the x-axis and actual, that is what you predicted as the y-axis. So we run this and then you can observe and look closely. All right, let's try to do something new whereby we can plot a perfect line of prediction. So I can come over here and still access that same axis. Then we use the plot function, which helps us to draw a line. And then we try to get our x values and y values. So how do we get our x values? So you can look closely, you see that the minimum in this particular list is 9 and the maximum is 15. The minimum over here is 9 and the maximum is 14. But they need to be the same. So we're going to take 15 as a maximum for the y values. So let's put that as small list for the x values and then for the y values. So they have to be the same. So once we run this, you'll see that we now have a perfect line of prediction. So therefore, you estimated that you were going to spend, let's say like $13 for that particular day, and then you actually spent that exact $13. So that is a perfect prediction that you made. So let's try to figure out what is above this line and what is below this line. So above this line, we can see that we have the estimated, that is what you budgeted for that particular day as $9, and then you spent $10. So therefore, you underestimated your budget. So then the rest of them, which is below the line, means that you overestimated. For example, you can take a look at 12. Now see that you got to estimate $12 to spend for the day, but then you now spent like 11. So therefore, you overestimated. So this particular visualization is now telling you that you overestimated your budget for the day. Maybe next time you could try to plan your budget, or you could try to reduce it by one so that it could fit into this line of prediction. So this is how you get to visualize something like this. So let's go over to the next plot, which is the right plot. All right. First thing we need to do is to get our error. So to get our error, so what I had to do is to come over here and then I import numpy as np. So we're going to use numpy to get the difference between the actual and the estimated. You could decide to use a for loop, but for this video I'll be using numpy, which is the one that I got to figure out at the time. So np.array, all right, and then we'll pass in the actual. That's what comes first, minus np.array. We'll pass in the estimated. Let's try to run this and see what happens. So we can see that we've gotten our values, but now it's still an array, so we need to convert it to a list so that we can easily plot it on our histogram. So we can now do something like this, put it in a bracket, then convert to a list. All right, you can now see that it is now on a list. So let's try to now plot it. First of all, access that particular axis. So in accessing the axis, we're going to now use the function hist to be able to plot our histogram. Then we'll pass in error as our data. Then we can now make a very simple plot. So you can observe and look closely what we have. So let's try to also modify or put our bins. Let's say tree. So for this video, I'll be using tree. We'll try different ones. So let's try to count it. We cannot even count it very well. So let's put our edge colors so we can easily count. Let's say white. All right, so now you can see that you can easily count the bars. So we have 1, 2, 3. All right, let's try to put our vertical line at 0. Then I'll still come to. So we'll pass in 0 first. And then let's try to, let's put the line style, or let's put the color first as red. And the line style as a colon. So it provides for us something that we can easily read. Let's try to read this visualization. If you now look to the left, you will see that we have a cluster of negative arrows compared to the right. So take a look at the cluster with a frequency of 4. The negative error literally means that you overestimated. And we have the 0 error, which shows no correlation. And then we have positive error, which will show that you underestimated. And then we now see that the tallest bar falls around the negative region, which is the negative error. So this is how we can easily make a scatter plot and a histogram. So let's try to clean our layout with plt.tight layout. Right, that's clean. Then we try to show our image. Let's go over to the cheat sheet concept. You can have a look and see the line plot. All right, helps you to identify trends. The scatter plot to show relationship between two things. The bar chart helps you to compare categories. The histogram, you can think of it as distribution buckets. The bins, you can think of it as number of buckets in a histogram. So this is a concept that you could imagine that could help you to retain, what we've been talking about in this video. You could also try to figure out or try to formulate. All right. So let's go over to the homework or the recall test. So what you need to do is to find a CSV file with an edge column and plot a histogram on the left and the bar chart on the right. If you get stuck, then you can now Google and figure out what you missed. That will be the best, and that will be all for today. Thank you.